Hi, my name is Sebastian and welcome to my video that will hopefully give you a better understanding of a geostationary orbit. All begins with Kepler's third law, which is the ratio between the orbital period and the semi-major axis of a particular orbit multiplied by a certain factor. The factor itself is determined by the gravitational constant and the mass of the central object, or in our case the mass of the Earth. However, the product of the gravitational constant and the mass of our Earth is known to a much greater precision than any of the values alone. So we end up with μ, the geocentric gravitational constant, and this is this number shown on the slide. If we now want to compute the orbital period, we just have to take the square root of the formula and we end up with this equation shown at the bottom of the slide. I now like to demonstrate you this equation with a low Earth orbit example with the International Space Station. The ISS currently orbits at a mean altitude of 413 kilometers around our Earth. Now we can take our shiny formula and notice that I've exchanged the semi-major axis with the radius. I was able to do so because we are talking about a circular orbit and we are having a more massive object orbited by a small object, the International Space Station. But what is a radius? The radius extends to the center of mass, so we have to take the mean radius of our Earth and add the altitude of our space station. Finally, we end up with a radius of 6,784 kilometers. Now we know all the important values and we can plug in these numbers into our formula and we end up with an orbital period of 5,561 seconds or 92.7 minutes. This is pretty accurate. But how does Kepler's third law help us to develop a better understanding of a geostationary orbit? Well, at first we have to remember that our Earth is rotating around its own axis and a full revolution of our Earth takes 23 hours, 56 minutes and 4 seconds. At this point, don't get confused with the length of a day, because the length of the day is influenced by the fact that our Earth is orbiting around the Sun. Now we know that the Earth is rotating around its own axis, and in order to stay above the exact same position, we need to have an orbital period which has the exact same length as one revolution of our Earth. So we can say that our orbital period has to have the exact same time as one revolution of the Earth. Additionally, an equatorial orbit is required because as soon as we have an inclination to the equator of our Earth, we will start to shift a little bit our position and we are not constantly above the same exact position. Now we know the orbital period we need to achieve, and so we know all the important values except for the radius. So we can solve our shiny formula for the radius and then we can plug in these numbers and we end up with a radius of 42,164 kilometers. However, we have to remember that we want to compute the altitude for a geostationary orbit, so we have to subtract the radius of our Earth once again. Notice that this time the radius is a little bit larger, and this is due to the fact that I now take the equatorial radius of our Earth and not the mean radius. Finally, we end up with an altitude of 35,786 kilometers, and this is the altitude for a geostationary orbit. And this is all about the great functionality of Kepler's third law, that we do have the ratio between the radius and the orbital period. So if we have a certain orbit, we can easily compute the orbital period, or if we want to achieve a certain orbital period, we can easily use this formula to determine the right altitude. Now, last but not least, what are the use cases for a geostationary orbit? Well, the geostationary orbit is useful for weather satellites, for communication satellites, and for television and radio broadcasting satellites. Additionally, the geostationary orbit has also good use for defense satellites and for intelligence satellites. I hope you learned a little bit more about a geostationary orbit in this short video, and I hope you liked my short explanation. If you do so, then I hope I will see you in my next video. Until then, my name is Sebastian. See you!